In this video, I'm going to connect the DRV8833 motor driver board from Adafruit to Raspberry Pi Zero. Instead of connecting an actual motor, I'll use a multimeter to verify that everything works correctly. I will use Codex to generate a Python script. The script flips motor direction every 5 seconds. This is how the driver board arrives. It comes with a small breakout board, and the header pins needs to be soldered before we can use it. Once the soldering is finished, it's a good idea to clean the board. Remove any leftover flux. After that, the board is ready to use. Next, we need to understand how the board works. Most breakout boards have documentation on the manufacturer's website. However, the most useful information usually comes from the chip's datasheet. So let's look at that. The easiest way is to go to the DG key and find the chip by name, and then go to the chip description and click on the PDF with the information about the chip itself. Here is high-level schematic, and it's interesting that there is no dedicated power input for logic and for the motor itself, so there is only one input. These are inputs and outputs of the chip. Worth noting and sleep. We will need to supply a high from a pin of 0 to make sure the chip is actually working. And here is the explanation what high and low means for this chip. 2.7 and up is high, which implies when 0 pin is up to 3.3 volts, this chip will see it as high. Here is the control logic for the chip. We're going to use input 1 and input 2. For channel A, we're going to send zeros and ones opposite, and that will force the motor to go either forward or backward. The table shows levels for out 1 and out 2. Low means ground, H means high, which implies the motor will go either one direction or the other. On our board, these are inputs for channel A, and the channel A outputs are on the other side. Sleep is next to the input, and ground and power are right here. We need 5 connections from this board to Raspberry Pi Zero. 1 is for ground, 1 is for power, 2 for a channel in, and 1 for sleep. Let's find them on the 0 pins. Let's find the pin out for Raspberry Pi Zero and pick GPIOS, which is convenient to work for us. Based on the diagram, here is our ground pin, and the other pin is 3.3 volts. Also, we need 3 pins for sleep and channel A input. 16, 20, and 21 seems is a good choice, mostly because it's easy to locate them on the board. Time to use Codex to get our script to change motor direction every 5 seconds. Requirements are pretty simple. Pin 16 needs to be high, pin 20 and 21 needs to be high and low and be opposite to each other and swap every 5 seconds. As simple as that. A quick code review. Lines 12 to 14 set our initial state, which is pin 16 pin up for sleep, and the other 2 are opposite to each other, one high and low. And the loop on the line 19 swaps them every 5 seconds. Now it's a good time to fire up the 0 and validate that pins actually work as we expect using our multimeter. So while the 0 is loading, we already can validate that the power pin is top left and the ground is bottom left as well. And we see 3.3 volts when my hands are not shaking. We're going to add our jumper cables. We'll start with the power one and then add ground. After a quick upgrade to the multimeter, we're going to connect it to the board in a more permanent state. And indeed, we see 3.3 volts on our device. Let's add other 3 jumper cables for pin 16 based on the diagram, pin 20 and pin 21. We are going to take our end slip pin and connect it to the multimeter to see when it goes high when our script gets working. Our script gets uploaded to the 0 and I'm going to execute it there. As soon as the script starts working, we can see that our pin 16 is going to go high. Now we can validate pin 20. It's supposed to go high and low every 5 seconds. So it's low now, and in a couple of seconds it goes high. The other pin is opposite, so we can wait until this is low and that is going to be high. And again, they're going to keep flipping as the script keeps working. With the script up and running, we are going to connect the multimeter to channel A output, so the multimeter will play a role of a motor. Connecting the rest of the pins following levels on the board. Ground goes to ground. Input of the channel A goes to pins 21 and 20, and pin 16 goes to sleep. Our multimeter shows nothing, and as soon as we're connecting power to the board, we're going to see our motor up and running, and the direction keeps changing every 5 seconds.